Hello everyone. Previously we talked about the design criteria mentioned in NVS 15 about the dry pipe and deluge systems. In this video I will discuss all the requirements and essential requirements of the pre-action system. It is similar to the dry pipe system, but with some differences. Most authorities prefer pre-action as the delay in water system activation and water delivery time to the most remote sprinklers is less than dry pipe system. Let's first discuss the three different type of pre-action system we can discuss on this diagram. As we can see here, these are the sprinkler heads connected to the main dry pipe, and this dry pipe may or may not be filled with compressed air or nitrogen. This pipe connects to the pre-action valve and is the dry side, and this is the wet side from the main water supply from the external network or the fire pump supply. We have to use a main control valve, isolation valve, with a strainer to remove any impurities in the main water from the main water stream. Then you have to use a check valve. The purpose of this check valve is that we have to use a fire department connection for this system. You have to use a fire department connection, minimum 2 multiplied by 65 millimeter to 2.5 inches fire department connections or landing valves connected to the main line. To prevent the water supplied from the external source to return back to the external network, you have to use this check valve. And the pre-action valve have to be supplied with drain line, test and drain line with a pressure gauge, a bypass line with an isolation valve. This is the purpose of the bypass is in case of the failure of operation of pre-action valve, you can manually activate the system by through this valve. According to NVS 13, the minimum size of the main drain should be, or the maximum size should be 50 millimeters or 2 inches of drain. And this drain can be connected to the sewer network through a sump or an intermediate chamber between the system and the external sewage or drainage network. Now you have to fill the dry pipes or empty pipes with compressed air or nitrogen. And we have three systems. The first one is the non-interlock pre-action system. In non-interlock pre-action system, activation may be either from the ceiling detectors connected to the control panel, which activates the pre-action valve, or it may be activated by the sprinkler elements. Each sprinkler has a responsive heat element, which explodes in case of fire, explodes and water flows through the nozzle or sprinkler. So in non-interlock, you can activate the system either by the sprinklers or the detection system. In single interlock pre-action system, activation is by a signal from the detectors to the pre-action valve and opening of sprinklers. Air inside pipes is not pressurized. So to activate the system in single interlock, you have just to pick a signal from the detectors through the control panel to the pre-action valve. And sprinklers opens or open by heat effect and the explosion of the sprinkler head. In double interlock pre-action system, activation is by both means. The first direction or signal comes from sprinklers explodes. Then the compressed air or nitrogen pressure drop down as the air escapes or nitrogen escapes from the opened sprinkler. By the reduction in air pressure inside pipes, pre-action valve have a differential clapper kept closed by the air pressure or nitrogen pressure. Once the air pressure drops, the pre-action valve or clapper opens, allowing water to flow. The second signal comes from the detectors. So to open the pre-action valve, you have to drop the air pressure or nitrogen pressure below the design pressure. This is the first signal. The second signal comes from the detectors through the control panel. And this is the usually followed system in freezing area, cold storage areas, or areas with valuable items like libraries, museums, and similar applications. We have here the filling line, the compressed air or nitrogen filling line, and we have to talk about the difference or the advantages and disadvantages of using a compressed air or nitrogen. For nitrogen, it can be supplied through cylinders, and the benefit in using nitrogen is it will not corrode the pipes. If you use a compressed air is used, it contains moisture in temperatures below the freezing temperatures of spaces will condense inside pipes and may freeze and block the flow of water in case of fire through the pipes. And in addition, the piping system will fail if ice is formed inside pipes and it shall be heated or in maintenance period, the space or the space, the storage area shall be shut down, the freezing system shall be shut down, and heating system will be activated to transform any freezed iced or formed ice inside pipes to liquid water that can be drained easily through flushing connections, test and flushing connections, or auxiliary drains, or the main drain, as I will talk now. So this is the benefit in using nitrogen. But its cost is higher than compressed air. Cost of generating nitrogen through nitrogen generators has a higher cost. The minimum pressure of the compressed air or in the pipes, according to NFPA 13, is 2 point or 1.4 bar higher than the valve tripping pressure. You can say you have to refer to the catalog of the manufacturer of the pre-action valve and to check the minimum or recommended air pressure inside pipes. Usually, it is 1 over 4 of the stagnant water pressure inside pipes. Uh, let's talk about in a real example. This is a freezing area or cold storage area. The total area is 100 meter length and 100 meter wide. According to NFPA 13, the maximum area covered by a pre-action valve shall not exceed the maximum area that can be protected by a normal zone control valve. Sprinkler system with a zone control valve, station, gate valve, check valve, flow switch. According to NFPA 13, we can check the area limitations for light hazard 400, 4830. Ordinary is similar to light hazard. For extra or high piled storage, this is our case here. The maximum protection area is 3720. So the maximum area protected by a single pre-action valve shall not exceed this number. Another restriction is the maximum number of sprinklers. Maximum number of sprinklers protected by a single interlock or non-interlock or even double interlock reaction valve shall not exceed 1000 sprinklers. So the area can be divided into 4 sections, each section protected by a dedicated reaction valve with a drain connection, as I mentioned, 50 millimeter pre-action test valve, test and drain line. Prefer to be free discharging, not connected to the drain network, and terminates with a 45 turn elbow. And the minimum length of this pipe or the drain pipe inside the valve enclosure. By the way, you have to keep the valve enclosure heated above the freezing temperature to keep water warm and avoid water freezing uh, inside the path of the reaction valve. Here you can find the drain connection with a 45 turn L. This is the fire department connection with a check valve connected to the main pipe supplying this valve. And this is its diagram. Main isolation valve, check valve, and another check valve after the pre-action valve. The purpose of this check valve to prevent any water to flow back in the main network. The purpose of this check valve to prevent the water from the fire department connection to flow back to the main network, and the purpose of this check valve to prevent water from the network or inside the building to flow through the fire department connection. So as I mentioned, the enclosure of the pre-action valve shall be heated. After locating the pre-action valve, you can locate your sprinklers. and this is not our topic now. You can check NFPA 13 requirements regarding sprinklers or sprinkler head requirements in storage areas with a normal K factor and flow rate and the density requirements. And the spacing requirements usually similar to extra hazard, 3 meters, maximum distance between branch lines, 3.7 meters, and between sprinklers on the same branch line in also 3.7 meters. Um, Additionally, the most remote branch line or sprinklers on the most remote branch lines shall be drained to external, to a safe location, uh, in a safe external location outside the building. And NFPA 13 determined the requirements of this drain connection. For light hazard, here we can find the table describe the number of most remote sprinklers initially open. It assumed that during a test period, there is a simulation similar to a fire condition or a condition of opening certain number of sprinklers. For light hazard, you have to consider only one open sprinkler, ordinary, two sprinkler, extra hazard, or sprinklers. And the associated time or maximum time of water delivery to these sprinklers or these remote sprinklers shall not exceed these values to ensure the compliance of the system with NFPA 13 requirements and to avoid the delay in water delivery to most remote area. The delivery time of water after the activation of pre-action valve through detection or open sprinkler's head or the drop in air pressure, the maximum delivery time shall not exceed these values. For extra hazard, it shall not exceed 45 seconds. So the duration, these are empty pipes filled with compressed air or nitrogen to allow water to reach to this location in a certain time and period. This period shall not exceed 45 seconds. Water delivery time shall not exceed 45 seconds after system activation by detectors or opened sprinklers. And the drain connection have this configuration. The simulation will be for opened sprinklers, the water flow from the test connection through 4 opened sprinklers. Here we can find the configuration from the most remote 2 sprinklers in the first remote branch line. This will be the test and drain connection. Equipped 1 inch or 25 millimeter, equipped with an isolation valve, ending with 2 orifices. These orifices are equivalent to 2 opened sprinklers. And another drain pipe, here as we can see in this figure, from most remote branch line a connection with two orifices. The second remote branch line also equipped with these orifices. Is the most remote branch line, the 1-inch drain pipe equipped with isolation valve, with a plug for testing, and terminates outside the building with a smooth pore corrosion resistant outlet, 45 turn elbow. Also, you have to note to facilitate the drainage and flushing of the network after testing or after fire condition. If the warehouse initiated or the freezing system activates, the water, the residual water inside the pipes will also freeze inside pipes. So you have to ensure all water has been drained from the system. And you have to follow these factors. The first factor, all branch lines shall have a slope with a minimum pitch of 2 mm per meter toward the main drain outlet. And for the main pipe, the minimum slope or cross main, the minimum slope is 4 mm per meter. And the cross main shall terminate with a minimum 1 and or 32 millimeters flushing connection with an isolation port. Any trapped sections of piping due to coordination. And let's take an example. We have a trapped sections, U-trapped sections. Drain points will be collected at these locations. You have to use a 1-inch or 25 millimeter connections to these trapped sections. For the purpose of hydraulically calculating the minimum pressure and flow rate, NPA 13 necessitates the use of the density curve to calculate the minimum density. And in our case, if we are talking about an extra hazard with a minimum flowing area of 2,500, the minimum flow rate will be 0.3 GBM per feet square. As this dry system, the design area shall be increased due to the delay of water delivery. Due to the delay of water delivery, more sprinklers will activate before the water reach to the hazard. In a normal condition, let's assume we have a fire with this limit. Due to the delay in water delivery to this area, the fire cross will be higher and will extend to open another areas or open more sprinklers. So you have to multiply by 1.3 factor the design area. The maximum design area will be 1.3 multiplied by 2,500 feet square most remote. After calculating the minimum residual pressure and flow rate at the reaction valve, you have to to check an important parameter or factor, which is the delivery time. The delivery time limit here is 45 seconds, and 45 seconds, and it will to be calculated or checked, you have to check this parameter, you have to use a software produced by TYCO. Its name is Calc or SprinkCAD. It calculates the delivery time to the most remote Russian connection or test connection, as I discussed here. It predicts the empty volume or calculates the empty volume of dry pipes, and based on the flow rate, it determines if the delivery time will exceed or be lower than the 45 limit. We can also find here a schematic diagram of the compressed air supplied to the dry pipe or pre-action valve in a freezer or cold storage area. To keep moisture low inside the air, compressor may take the air from the freezed area or refrigerated space, then supply it through a dryer, air dryer, desiccant type dryer to remove any moisture, and then the pipe passes inside the refrigerated space and connects to the dry pipes through a check valve. As we discussed in this schematic, is a similar diagram: isolation valve followed by a pre-action and a check, then a normally open control valve. This valve should be closed in testing condition to prevent the water to flow in test period. To prevent the water to flow inside the system, you have to close this valve and open the test connection or drain pipe connected to the pre-action valve. The software produced by TYCO, its name is SprinkFDT. You can purchase it from their website or use a demo version. And this software is UL listed and approved by the authorities or approving agencies, civil defense approving agencies. You can calculate the capacity of the empty pipes for delivery time calculation according to this table. There is a capacity of 1 feet of pipe based on actual internal pipe diameter or nominal pipe diameters. Here, according to the schedule of the pipe, this is the volume of the pipes or the internal volume of pipes. You can find here all the summarized here. I summarized here all the important notes and points from NVA 13 regarding the reaction system in normal occupancy buildings or in storage warehouse. Thank you for watching, and for any you can leave any question in comments regarding this system and installation requirements. And for the software, as I mentioned, you can refer to TYCO website or and to cache the full version. Thank you.